Welcome to a brand new section in which we're going to tackle the player movement. In the previous one, we managed to create a nice world that was automatically generated and also have our inputs listened to. We were not using them just yet, but at least they were being listened to. And in this section, we are going to be making our character move. Now, please bear with me. It's not complicated code per se, but it's a little bit more in depth than what we've been doing thus far. It's going to use a state machine, which is a design pattern that will allow us to separate our code in such a way that it's going to be readable. And also, you can build more on top of it without clustering too much. So, without further ado, I am going to go under the script, right click, and create a new folder called Player Motor. All the magic will happen right in here. In this first video, we will create the motor script, the script that controls it all. And then after that, we're going to branch into making different states, such as running, falling, jumping, walking, dead, idle, all this kind of stuff. But in the very first video, we are making the base script. And it's going to be quite, that's where most of the logic goes in. So it's going to be quite complex, actually. So this one is going to be called Player Motor. And we are going to open it up and get ready to code because we got quite a lot of field to declare at first. The script is going to be split in two sections, as always. We are going to, at the top, declare all the fields we'll need, and then use them in separate function just beneath it. So I'm going to start by cleaning everything up, and we're going to head into making those fields, declaring those fields. So I will start by declaring a couple of fields that will be hidden in the inspector, so hide in the inspector, but they will be public. The reason they will be public is because I'd like to access them from somewhere else. So that being said, the first one is called move vector. The second one is going to be a vertical velocity, which is a float. Third one is, what was it? It is grounded, so whether or not we are grounded, I'll go ahead and I'll explain all of them once I'm done declaring. So is grounded, and finally, the last one, that is public, but also hidden in inspector, is the current lane. Okay, so let's go over these four fields. Move vector is how far away are we going to move this frame. This is very specific to this frame. We're going to move exactly this far away. Vertical velocity is going to be all about my velocity when I'm jumping or when I'm falling. So if I'm jumping, this will be positive. If I'm on the floor, this will be -1 or something very, very little. So it keeps us on the floor. It acts as some sort of gravity. And if it's negative, we're free falling. Grounded is to know whether or not we're touching the floor. And current lane is whether or not, but it's a int that will be used like so. So -1 is going to be left. Center lane will be 0, and 1 will be the right lane. Okay, and then right after that, we got a total of 5 fields that we have to declare, 5 float actually, and those will all be configurable field. First one is going to be a distance in between lane. The way we've created our prefab, we made sure to keep 3 meters in between each lane, so I'll do that here as well. Next one is the base run speed. How fast do you run every second forward? Second one is going to be the base sideway speed. This is going to be a little bit faster. So I'd like to move faster left and right than forward at first. Because switching lane should be fast. It's an action the player wants to do. So let's try and make it really fast and make it snappy. Next up, we have the gravity. So how fast are we going to reach the floor when we jump? And how fast is our jump going to be? So if you're jumping, how long are you going to stay going up for until you start falling? And finally, terminal velocity. Terminal velocity, which is roughly around 20. So these are settings I've used from my other games, and it works perfectly fine. Did I forget something? Yes, I actually overwritten the base sideways speed. My bad. And the final field is going to be reference. So public character controller. I'm keeping a reference to the character controller, so I can call the .move on it. So here, hidden fields. Here are the configurable fields, and here is the reference. Now we have that. I'm going to start by declaring a private void start. So when we start, let's go and grab a reference to the character controller, just like so. Now we do have that reference. We can move on and create the update. This is where all the magic happens. So this is where we should be moving our character. However, I like to keep my function in different capsules, so encapsulated, and I feel like we should split that apart and actually create another one called private void update motor, and just call update motor in the update. So in case we want to do something else later on, then we can just put stuff in the update and it's going to be well separated. So in the update motor, what do we have to do? There's going to be roughly 4 steps to do here. First off, check if we're grounded. And the reason I'd like to do it once per frame is because it is an operation that costs something to do. So we already have this information in controller is grounded. However, our state will be asking this question quite a lot. Are we grounded? Are we grounded? So might as well keep it in cache for the frame. So we can say is grounded is going to be equal to control is grounded. And instead of calling this all the time, I'll just be calling the one that we made. Okay, so this is just for optimization. Second step is going to be about asking our state, how should we be moving right now? So how should we be moving based on the state? We actually don't have that information just yet. We don't have the concept of states. Then, are we trying to change state? Again, we don't have that information, so we're just going to leave it blank. And for the final step, the most beneficial one, move the player, in which we'll do a controller.move, move vector, times time the delta time. We will go over this once more. We have 4 different steps. First, let's cache some value. Second, we're going to ask our state, and now I'll give you an example. Our state could be walking, running, jumping, falling, deaf, are we idle? We ask someone else how we should be moving right now. So another script is going to take care of knowing how to move around based on different inputs that we send it. So for example, are we swiping left? Third step is about, are we trying to change state? So assume we're walking and the walking state realized that we're swiping up and we're on the floor, then we would be trying to jump. So here it's going to keep looking in the walking state. It's going to keep looking, are we swiping up? If so, okay, then go ahead and enter the jump state. And then on next frame here, we'll be able to move according to the jump state. That is pretty much it. So we've made the big chunk of update motor. Yeah, actually. For this to work though, we're going to need a couple of more concepts in here. The state concept is the most important one. Okay, so we covered a good chunk of the player motor. To keep going, however, we're going to need to introduce the concept of states, and that's something I'd like to do separately in a different video. So this is actually where we'll be ending this one. Keep all of these in mind. Right now, the script obviously doesn't do anything. It's going to get a reference to controller and move regarding to move vector, but that's never actually being assigned, so nothing's really happening at the moment. But keep in mind that in the next video, we're going to introduce states, and those states will be modifying the move vector. So I'll see you there. So previously, we started creating the player motor, but we did not complete it. We still had concepts that were not introduced just yet, such as the state. So in this episode, we're going to go over this and actually create this concept. And it's the state machine design pattern, which is quite a useful one in our case. I'm going to create it in a different folder, however. I'll be calling this one state under player motor. And to introduce this, we are going to do the theory as we create the base state. So please just follow along for a bit and you'll understand a little bit more what happens once we open this one up and we put it through the flow. We now have a new script that is called base state. It inherits from model behavior, and that's totally fine. We'll just keep it this way. What this base state is going to do, it's going to be the parent class for walking, for jumping, for falling. It's going to be the parent that pretty much guides how state can behave. So all the functions we're going to be declaring within here are going to be inherited by walking, jumping, falling, deaf, idle, respawn, and all those different movement states. So let's go ahead. To implement a state machine, usually the most popular concept is to have three different functions that will be there for whatever state machine you're doing. It doesn't have to be a movement one. It could be bus AI. It could be anything really. But usually you always see the following three. First one is called construct, like so. Second one is destruct. And third one is transition. And you know what? Since I'm not implementing anything in here, I'm just going to go ahead and leave them on the same line. There we go. Okay, so every time that we have a state, it will have the following function: construct, destruct, and transition. Construct will usually be called once we first enter the state. Destruct will be called once we leave the state. And transition will be called in an update loop constantly to know whether or not we should be switching to different state. For example, we're entering the jumping state. Once we enter the jumping state, we'd like to set our vertical velocity to a certain amount. And then every frame, we're going to be checking in the transition, is our velocity right now equal to 0 or like smaller than 0? If so, we should be transitioning over to the falling state. And if we do transition over to the falling state, we're going to call destruct before we go. So those are all, I don't want to call them endpoint, but those are all steps that you will go through with every single state every time. So this will give you a nice code cave where you can input stuff as you're switching frames. Not frame, state. Okay, cool. It's getting messed up in my word here. However, there's something, this is like for all the state machine. Now, something specific to our game and movement in this case is the player motor. I'll keep you a reference to the motor here at all time. If you're not familiar, protected is basically the exact same thing as declaring a field private. However, your children will have access to it. So the walking state will have access, falling state will have access. As long as they inherit from base state, they will have access to motor. And finally, one more function that is only going to be specific to our game is the following: process motion. And this one is the one that we'll call directly from the update motor. This is the one that will determine how to move depending on which state we are in. What I'm doing right now is I'm just creating a debug function that will say, hey, if this is not implemented, so if there is nothing within that function in the children, we're just going to say, hey, it has not been implemented, and we're going to return a 0. Okay, so right now, this might be a little bit hard to wrap your head around, and I'm going to make it a little bit more complex by adding the abstract T word. If you don't know what it means, it basically means that you cannot just put this script on top of somebody else. It cannot exist on its own. It needs to be inherited. So base state, I save this, everything is saved. If I am to just drag and drop this on top of the player, it's going to say, no, you're not allowed to create this state on its own. It has to be a children. It cannot be abstract. Okay, so going forward with this, to understand a little bit better how base state is going to work, we're going to implement a new state. So I'm going to right click, create the running state, and we're going to go ahead and implement that. So we have a new state right here called running state. All we have to do really is the following: change the modal behavior inheritance to base state like so. And just by doing this, we now have access to a couple of things. Motor, oops. Well, we should have access to motor at least. Well, we're not in a scope, so we're not going to have access here. But we have we inherited from these 4 functions, and they're all virtual, which means we can override all of them. Now, for the example of running state, we don't need to do anything when we start running, and we don't need to do anything when we stop running. So construct and destruct, there is no need to override these because there's just nothing we do right now. Eventually, we're going to be triggering animation from them. But right now, to keep things simple, we just need to implement the following: transition to know whether or not we should be switching, and process motion. That's for knowing how to move. So going back in my script, I'll do a public override. Let's do process motion first, and public override transition. I'm going to remove the base. We're not going to be calling the base. We're going to be implementing it always like this. So now let's think about this. How do we move our player? We move our player. Well, first off, let's declare a vector. So for example, we can do m for move vector. We're going to start with a vector 3.0 and eventually return m. Now, how is our player moving around when he's just running? I will go ahead and declare that in X, I'll leave it to 0 right now. We'll come back and make him change lane, but at the moment when we're not moving in X at the moment. Secondly, in a Y, we are on the floor right now, so I always want to have a small force that will keep me on the floor. And finally, in Z, we'd like to move at a certain speed. That speed is defined in motor, so I'll do motor dot base run speed like so. And we've just did our math. So in X, we're not moving at all. In Y, we are applying a small force towards the floor. And in Z, we're moving at the base run speed. That's all we need to know right now. Now for transition, I'd like to look for a couple of things here. Are we swiping left? Are we swiping right? Or are we swiping up? Left will mean that please, change lane. Right would mean change lane on the other side. And up would mean change to jumping, actually. So I'll do the following condition. If input manager instance swipe left, I'll do something here. Right now, we don't have anything to change the lane, so I'll just open the brackets. I'll copy this over. Same thing for swipe right. And once more, but this time for swipe up. So here, change lane, go left, change lane, go right. And here it's actually changed to jumping state. And you know what? I forgot something here. If we're swiping up and we are grounded, then we're allowed to jump. If we're not grounded, I don't want to be able to jump. That'd just be weird. That being said, are we ready now to go implement these? I think so. So to make everything work, we'll have to go back in the player motor and first apply the process motion and also call transition and make sure we implement these three. So that's the three last thing we have to do. Fill in the steps in player motor, implement changing lane, and implement changing state. So let's go ahead and do that. Player motor. How should we be moving here now? Based on the state, which means we'll need a reference to that state. And that's where we introduce our new friend, state, written like so. This new state will be declared in the start initially because we need the starting state. We need the default state. And it's going to be the following. So get component running state. Because remember, we can't just apply the base state here since it is abstract. Once we have a reference, we'll call construct. Even though we know it doesn't do anything right now, we'll still call it. Okay. Then moving forward, right about here, this is where we're going to be asking the state. So move vector process motion, state.process motion. We're asking the state to process the current logic within the running state, which is this right here. And it will return how we should be moving if we're running. And then right here, make sure we call the transition. It's something we have to call every single frame to know whether or not we're changing. Our problem right now is that even though we are swiping left, right, up, we don't have any implementation of first changing lane and second changing the, what's the other thing? State, yeah. So down here in the player motor, I'll go ahead and I'll create the following function, change lane, which will take an int called direction. Could take a Boolean as well. Could take any type of parameter, string if you wish. Really doesn't matter. And then a public void change state, which will take in a base state as a parameter, just like so. When we change the lane, we just have to say current lane is going to be equal to current lane plus direction. But since we're only having 3 lane in our game, so I'm going to clamp it like so. With a mapf.clamp, the value is the following, so current lane plus direction. -1, and then 1. So we're clamping on both the left side, -1, and the right side, 1. That's it. So change lane has been implemented. The logic on moving our player around will be done in the next video, but at least right now we are changing the int that will then know what lanes we're on. So that being said, we are going to implement change state. Here's what we have to do. It's really fun. First, you call the current state. You say destroy, and then you say, hey, the current state is now equal to s, and then you do state.construct. That's all we have to do. Let's go back in running state and implement this now that we have these function. Here, it's a motor dot change lane -1, and here it's motor dot change lane 1. And finally, here is the following. So motor dot change state, and then we run into a problem because we don't have jumping right now. So it's going to be jumping state written like this. But since we don't have it, we're going to have to leave it on the bench for now, and we'll come back to it. Okay, are we ready to actually apply this? I think we're ready. We're going to get an early result, and we're still not moving left to right, but we'll see that in the next one. So I'm going to go right over to my penguin, make sure I add everything I need. You shouldn't have the character controller. I just did a little bit of testing here, that's why it's there. But we'll be applying the player motor. You'll see that we have all of these fields we can modify, and then add the running state as well. Then I'll hit play. It's going to tell me, hey, you don't have a character motor. So yeah, so go ahead and add the character controller. I'll move mine up. Here it is. Oh, and you also have to realize that this is going to happen. So you might want to change that a little bit. So the center should be at 0.5 and the radius should be at 0.25 maybe. Height on 1. And do know the bigger you make the radius, the harder your game is going to be, obviously. So I'll put that on 0.2, like so. Okay. What do we run into right now? So running state seems to not be defined. Let's see what happens. Oh, I missed something really big. Actually, I forgot something in the base state. I actually forgot to assign the motor. That's very, very important. So my bad on this. What we should be doing here in a awake call is assigning this motor by doing a get component, player motor. And now we should be good. Make sure you do that in the base state and not the running state. You could be doing it in the running state. It would work, but it would not be clean, and you would have to redo it every time there's a new state. So obviously you want the parent to have this reference instead. Okay, so once we start with this, once we have the button press, our player moves forward and then he gets stuck within the first rug that is in place. But at least he's moving. At least you know that the player motor is successfully calling another script right here to run. And for example, you could do something like this and you'd see that he'd be moving towards the right side. Just a tiny bit. So you know that another script is controlling the behavior of your penguin. And for some reason, mine is not moving. Maybe I saved a little bit too quick. Yeah, that has to be it. Okay, yeah, as you can see, he moved a tad bit towards the right-hand side. And if I was to put him here, slowly but surely, he's moving towards the right. So that's actually where we're going to be ending this episode. In the next one, we're going to go implement the changing of lanes, which is going to be very, very important for a player to move around and also to test the transition. Right now, we're not really testing if we're swiping up, left, or right. We can't really see anything, but technically it should change the current lane if we're swiping left or right, which is just the int right now. Okay, so that being said, I'll see you in the next one. In this episode, we're putting everything together, including the snapping to a certain lane and making sure our player can move left to right using input. So we're just making sure everything works within this one before we go and we tackle something else, such as the jumping state. So it's going to be a fairly simple, fairly fast episode, and we're going to start within the player motor because that's where some of the logic will happen. So the logic of snapping to a certain lane, this is where it will happen. And I'll input that right in between the update motor and also the change lane, because this one will be public. And I'll be returning a float. This function will be called snap to lane, and it will make sure that the player goes exactly where it should be. I will start by declaring myself a float called R for a return value. I like to do that sometimes. So I can just return R like so. And here we will branch in between two different logic. The first logic is going to be the following. So I'll do an if statement. If we're not directly on top of a lane, or actually the lane we're supposed to be on, then do something, else R is just going to be equal to 0. We actually don't need to move at all in X. So let's go ahead and write this statement. If we're not directly where we should be, which could translate itself as transform.position is actually position.x is not equal to my current lane times the distance in between lane. For example, if my current lane is -1 times 3, because the distance in between lane is 3, then -3. If we're not exactly at -3, let's enter this if branch and make sure we move exactly where we should be. And this is how we're going to be taking care of this logic. We're going to start by, we're going to start by declaring a delta to desired position, which would translate as how far away do we need to go before we're exactly where we need to be right now. And we can do this by knowing this value. So current lane times distance between lane. This is where we should be minus where we are right now. So transform position.x. With this, we know exactly how far away we have to go before we're exactly where we need to be. And we'll start declaring the R value based off that. So I'll do a small ternary operator here. I'll be looking at the delta to desired position. If that's bigger than 0, it means we have a positive value. So I'll put R is equal to 1 right here. And if it's not bigger than 0, then we're going negative. So I'll say -1. So at this point, R is either equal to 1 or -1. And then I'll multiply that. So time is equal by the base sideways speed. Knowing this value, for example, this is 10, I believe. Yeah, 10. Now we're either at -10 or +10. And we can just go ahead and move in the proper direction. So that's totally fine. It's going to be multiplied by time the delta time, so we're not going to run into a problem that it goes way too far away on a certain axis. So this right here could work, but technically, once we reach a certain point, we're going to see some jittering going left and right because it's going to go a little bit too far towards the right, and then it's going to see that the delta is now like negative, and it's going to go too far towards left, and then it's going to see that the positive value is there, then it's going to go too far towards the right. It's going to keep jittering. So what we have to do, if our distance right here, the base sideways speed, goes further than where we should be, then we need to clamp it to exactly where it should be so it stops. So here's how we'll be doing this. We will calculate the actual distance traveled, I'll just call it actual distance, by doing R time the delta time, because we know that eventually this value will get multiplied by time the delta time. So this right here is exactly how far we'll move this frame. And now what's left to do is to check whether or not the actual distance goes further than the delta to desired position. And if that's the case, we're going to have to clamp it down. So if mathf.absolute, I like to put that on absolute because these values might either be positive or negative. I'll make sure they're all positive within my operation here. So if the actual distance, if that's bigger than the absolute of the delta to desired position, which means is how far we actually move away, is it bigger than how much we have to move before we reach the exact spot? If that's the case, then we're going to say delta to desired position times 1 divided by time the delta time. Okay, if you don't trust me, here are the mathematics. So for example, time the delta time is usually something like 0.001 for me. Here we have base sideways speed. So if we have to go right, our base sideways speed is going to be r is equal to 10 because that's 10 and we have 1. Now we can calculate the actual distance by saying 10 times 0.001, and we're going to end up with 0.01. So that's how far we're actually going to travel this frame. For example, now, if the delta to desired position is actually on 0.005, so we are moving further away than how much we should move, then what we do is the following. We grab this value and we do times 1 divided by time the delta time. So here, I'll do it in the calculator here. 1 divided by 0.001, we end up with 1,000. And this is 1,000 on this right-hand side, and here 0.005. So times 0.005, we end up with 5. Initially, we had 10 here. Now we end up with 5 because we're halfway through. So this calculates the exact distance we have to go. And that's it. We've made our function. And that was the most complex function we had to create in here. And we are going to go and use it. So back under my running state now, we know exactly what to do with this number. We can say motor snap to lane. And that's perfect because now we're changing here. We're changing the current lane value with our swipe left and swipe right, which should be called, because technically transition is there. We should see this in effect directly in our game now. So going back in the game, let's see. Everything is there. I have the running state, the player motor, animator, and also the character controller. Let's press play and see if we run into any trouble. So my player should be right here, and I'm going to swipe right. And he moved towards this side, and he snapped perfectly fine. So let's see, his transform is exactly on 3. If I move left, exactly on 0. If I move left again, exactly on -3. Sometime when you move back to 0, you might get the weird ellipson value. So like a value that says -e something. Don't be scared of that. It basically means 0, but it's just that the rounding of the number in the computer world might mess this up sometimes. But as you can see, it works exactly as it should. However, our camera is not stuck to us, so let's do something this episode. Since we have not implemented our camera system just yet, let's make sure we actually follow our penguin around with this camera. And I'll be doing so by moving this over directly on top of my penguin. So I'll go ahead and I'll take my camera and drag it directly on top of the penguin, which should lead to the following result. We're starting to have something that works. And yeah, our world is being auto-generated because remember that the world is not actually attached to the player, it's actually attached to camera. So when the camera moves, then you get to see this behavior work. And obviously we might want to change the distance at which we have to spawn stuff for the scenery, but the rest seems to be just fine. And I can move left, I can move right. I'll have a lot of collider to fix, like this one here, we get stuck. So we'll have to go in this prefab and just make sure the collider is a little bit beneath this. But before we go and we start fixing these things, I believe we should finish writing the whole controller with a jump and also with a falling state. Yeah, so that being said, we will see each other in the next episode in which we will tackle the jumping behavior. So I'll see you there. In this episode, we're going to be tackling 2 different states, the jumping state and also the falling state. They pretty much behave the same exact way, but we'd like to know whether or not we're in a jumping or falling state sometimes, especially if you have different animation between the 2, and maybe you want to have some additional logic in there as well. So we're going to go ahead and right-click, create new states, 2 of them. So first one will be the jumping state, followed immediately by the falling state. And we will create the jumping one first and move directly inside of jumping right after. So double click on jumping state and you'll see how easy it is to implement now that we have almost all the pieces. There's 1 piece left that we'll have to create in the player motor, but we have most of the pieces left to do. So let's do a public override void construct. We'll be changing construct in this case, and also public override process motion, and finally public override transition. These are the three we're going to be overwriting. Now, one of the cool things that has to do with the way we split our script apart and also how this state machine work is that we can actually declare a field right here. For example, we can declare a public float jump force and have it apply only this state. So if we had two players running around and we want one of them to jump higher than the other, we just have to go directly on this component, which will be on top of the player, and change it for that player only. So it's a nice way to split. Again, we can split the field in different ways. So we don't have to put that directly on the player motor. These are fields that affect all the state, and this over here is field that will only affect the jumping state here. So that being said, let's go ahead and implement those. Fairly simple. Once we enter the state, once we enter the jumping state, we have to set the vertical velocity of the motor to jump force in this case. For the process motion, we're going to need to do two things. First, apply some gravity, and second, override the following that we have here. So I just copied over what I had in running state, but don't worry, you don't have to do that. Fairly simple to just rewrite all of that if you wish. Here, apply gravity. And second, create our return vector. So at the moment, apply gravity, we don't have any code for that. We'll create it in a second. So when it comes down to applying the gravity, it's something that should be fairly simple, and it will look like this. Motor vertical velocity is minus equal to the gravity times the delta time. The reason I do times the delta time here is to make sure that the gravity is going to be in a whole separate value, this vertical velocity. So I want to make sure it's synchronized just like the other value. That being said, this code will be reused at a couple of places. For example, we'll reuse the same exact code for when we're falling. And I don't like to write the same code twice. It's actually not a very good practice. Even though it's only one line, I like to keep it separately somewhere else. So if I have to rewrite this for some reason later on, I can overwrite everything else, like every other place that has this. So what I'll do, I'll actually grab this line of code and I'll put it under the player motor here. And I'll do the following. Public void apply gravity. And I'll paste it. Remove the motor. We don't need to reference that. Don't need to reference that as well. And I'll simply be calling that from the jumping state instead. So I'll say motor.apply gravity. And now we just put that under a different field, a different function that I will also call from falling, so I won't have to write the same code. Okay, what else do we need? Now, okay, let's go ahead and create our return vector. Snap to lane in X is going to remain the same. Now, in terms of Y, this is where it changes. Everything changes around here. So the Y component is actually going to be equal to the vertical velocity. And Z is going to remain the same, unless you want to slow down a little bit while you're jumping. I don't know why you do that, but you can control that here if you wish. So that's pretty much all we had to do for process motion. And finally, transition. One thing that I don't want to do. So for transition over here, we made sure we can change lane left, right. I actually don't want that in the jumping state. Instead, the only thing I'll be looking for is not even inputs. I'll be looking for the following. Is our vertical velocity, so our force in Y, is it now smaller than 0? And if it is, go ahead and change state for falling. So if we stop going up at one point, which we will, because gravity affects us, we are going to enter the falling state. It's not going to work right now because falling state does not inherit from base state, but it will in a second. So if I just press F12 on this one, change it here, the jumping state now works. Okay, before I go and I code the falling state, I'm going to go back under running, make sure I uncomment this. And I'm going to give it a test. I want to see if everything works well before I move on to creating the falling state. So pressing on play here, I can move around left, right, yeah. And here I'm going to jump. And we're actually going to run into a problem for the sole reason that we did not include this on top of our player here. So here's what I'll do. Make sure I have my running state. jumping, and also falling. Let's preemptively do it here. Then I can press play. You'll see my jump force is public, so I can modify that here if I wish. And I'm currently falling a little bit. I'll let myself fall so we can see this clearly, and I'm going to jump now. So here, as you can see, we jumped and then we got stuck in the air. And the reason we're stuck in the air is because process motion is actually not implemented in falling state. That's right. So we moved on from walking to jumping, then into falling. So we were able to call the falling state. The problem is that we don't have any code in falling state, so it doesn't know how to behave. And here is the fun part. That's actually something I was looking forward to doing in quite a while. Creating the falling state. Let's see how simple it is going to be to create a falling state with this system. We're going to override two things. So override process motion and also public override transition. For this one, I'll go and I'll grab whatever I have here in the jumping state, apply it here, and let's have a look. Yes, we apply the gravity. Yes, we create a return value. Yes, we still snap to lane. This is still equal to velocity. In this case, it's going to be negative, which is still good. We still want that. Oh, actually, we could clamp it. Yeah, so it's going to be equal to vertical velocity. I just realized something. We're going to go back under the player motor for a bit. And also Z, we apply the speed forward. That's totally fine. So we don't need to change anything within the process motion. But under transition, here is what we're going to be looking for. Are we grounded? If we are grounded, let's go ahead and change state to running state. That's all. That's how simple it was to implement the falling state. Basically copy paste, and we just different transition. Really, that's all. Something I've realized that is not going to change much if you forget about it, but let's go ahead and do it. Under gravity, I'd like to clamp this with my terminal velocity. So if vertical velocity is now smaller than the minus terminal velocity, I'm going to say it's equal to it, to minus terminal velocity. This way, if it goes beyond 20, then our speed is going to be capped at 20 meters a second, which is quite a lot, actually. But still, I don't think we'll ever realize this or see this simply because we don't reach terminal velocity unless you're falling in a hole and you didn't plan for that. But yeah. Okay, we should now be good to go to have a full loop of this player running around, jumping, falling, and then going back into the running state, which is the most important part. So having a full circle. So let's go ahead and see how it works. Oh, wait, we see a problem right here. So if I am to jump, I do the full loop. So jump here, then I fall, and that's perfect. I can jump again once I'm in the walking state. However, if I just decide to fall off like so, without jumping prior, you'll see this problem. We're just floating in the air, and we're technically, right here, this is technically in the walking state for the sole purpose that we didn't jump. So there was no way to transition away from running state here. There's nothing that says, hey, go to falling state if there's no floor beneath you. So that's what we'll do here. In my running state, input manager, actually, no, wait, is grounded. If we are not grounded like so, then go ahead and change my state to falling. There we go. So that's all we were missing here. And I'm going to remove these extras. Now, if we're not grounded, we will go straight to the falling state, which will mean that vertical velocity will be applied. Now, we seem to have a small issue where we fall extremely fast if we don't jump prior. Let me just give you an example. Right here, you'll see it. We will fall extremely fast off this if we're able to get on it, which I guess is not the case right now. But what really happens here, and I'll explain it the best I can, is we never reset the vertical velocity after falling is done. So once we reach the floor, we never reset the vertical velocity. So if you end up like running like this, it's really hard to do it, but if we move this way, you'll see it really snaps very fast to the floor because the vertical velocity is still quite high which means that under my running state, when I enter the state, I'm actually going to put that back on 0. So once we hit the floor, let's actually reset our vertical velocity. And I can do it like this. So with a public override construct, and I can say my vertical velocity at this point is going to be equal to 0. So with this code in place now, once we reach the floor, once we enter the walking state, we are eating the shock that happens. You hit the floor, we eat the shock. Our vertical velocity is now back to 0, which makes a lot of sense. And that's actually where we're going to be ending this episode. We're starting to get a nice little flow. Of course, the animation are not in there yet. That's going to be a step we'll have to do. We'll have to fix some of the prefab because sometimes we just don't go up, and that's really annoying. Maybe we'll fix that directly on the character controller. But that will be for the final episode of this section, where we just make sure everything works and tackle all these small issues. Until then, we still have a couple of states to create, such as the wristbound state, the idle state, and the dev state. So that's what we'll move on to do next. So just stick along. We're almost done, and we're about to get a very nice result. So I'll see you guys in the next one. In the last episode, we left off with the jumping and also the falling state. In this one, we're going to tackle the sliding state, so the one that is going to make our collider a little bit smaller and allow us to go beneath those obstacles we have in our course. So let's go ahead and right-click on state. We are going to go and do the exact same thing we always do when there's a new state. So call it sliding state. And we're going to make sure this one inherits from base state. So let's double click, open it in our best editor, and we are going to change. And here it is. It's now open. As always, I like to clean up everything. So let me get rid of all of that. We're going to be using base state. And what are we going to override in this case? Well, let's declare a couple of fields first before we override. There's a couple of parameters we'd like to be able to control. So how long is the slide going to be for? For example, if our slide is 1 second, it's going to give 1 second per player to go beneath the object. Now, of course, the longer this is, the easier it's going to be for him. The less you have to time exactly, be frame perfect to go beneath the object. And that's pretty much it. So in terms of other data we'd like to keep, there's 3 other data I'd like to keep internally for the logic of this to work. So it's going to be collider logic. So private vector3 initial center. And you'll see why we do that in a second. Private float initial size. And also I'm going to keep a float for slide start. Now, respectively, those 3 are: where is the center of our character controller? What is its original size? So how big is the radius originally? And then when exactly, this is time.time. So when exactly does the slide start? And let's go ahead and start overriding things. This one is a lot more complex than the rest of the state, simply because we're modifying the character controller on the fly. So we're going to start with a construct override. Whenever we enter the sliding state, I will go and start the slide with slide start time is equal to time.time, which is going to give us a exact timestamp of when we enter the state. This is going to be useful so we can transition out of it eventually. Now, as we're constructing this, let's also make sure we have the initial size, which is going to be equal to motor.controller.height. So we access right here. What we do is we access the character controller, and there's a reference of it on the motor. Next up, the initial center, motor controller center. And then what we do, once we save these, once we have the data for where the character controller is, and I'm just going to show it to you at the same time so you understand what I'm talking about. Those fields are they're exposed, so you'll be able to see them as well. Here they are. So we had height, which is this one, and we had center, which is this one. So when we modify height, for example, 2, or in this case 20, our penguin grows, like the collider grows. So what we're going to be expecting to do when we go in a slide mode is maybe reduce that to 0.5. So he's definitely smaller and he can go through beneath object. But we're also going to have to move the center so it snaps to the floor, like so. So these 2 values are going to be the one we're going to modify. So right here we have center and height. Here they are, center.height. Now, when we enter slide mode, well, we're going to modify these. So we just grab a reference to them. Now we're going to say, hey, the height is going to be equal to, for example, initial size divided by 2. Or if you'd like to be a little bit more compiler friendly, you're going to do a times instead. Actually, if you want to be even more fancy than that, you can do a byte shift. I don't know why I just went on a tangent, but okay. That being said, same thing for the height. So motor.controller.center initial center. Oops, initial center can't type. And we're gonna divide that by 2. So these values are gonna be divided by 2 as soon as we start. So what I just shown you here, height 0.5, and also center is going to be like this. So we end up having this small collider instead of this big one. Now, the reason we kept them in memory is simply so we can put them back to what they were in a public override destruct. So here, in the destruct, I'll simply grab this, paste it, and remove the divided by 2. So simple enough, we just go back to the size we were initially. Now it's time for transition, because transition is going to be a bit different than usual. So if I go and I override my transition, we'd like to be able to do a couple of things. So when I'm sliding, I'm actually going to allow the person to slide left and right, so in between lanes. So I'm going to keep the logic we have here. So being able to change lane is going to be possible while sliding. Now there's going to be additional logic in here. So for example, if we're sliding up and at one point we fall off an object, so if we're no longer grounded, I'd like to get into a falling state. So get component type of falling state, just like so. Okay, so that's the first one. Second, if I am currently sliding and I'm jumping and I'm trying to swipe up, so input manager instance swipe up. If the person managed to do a quick swipe up, then let's go into a jumping state. So you can jump off that state. And finally, one more. If the time ran out, we're just going to go back to walking state, or running state, my bad. Now, how do we actually say did the time run out? We do it this way. So the current time right now minus when we started. So remember, this is a timestamp as well. So the time right now minus when we started gives us how long has it been since we started sliding. If that's more than the slide duration, then we can go ahead and enter the running state. And that's pretty much all we need here. We're going to be testing it out right now. The only problem is that you won't be able to see it physically. Or I don't want to say physically, but you won't be able to see it because there's no animation around it. And since we're changing our side of the controller to a point where it's still going to be on the floor, then it's going to be very, very hard to tell unless we pause the game and we look at the actual character controller. So let's go ahead. I'm going to add this sliding state right here. And you know what? Just for testing purpose, I'll put the slide duration on 5 seconds. And I just realized we have nothing to go into that. So let's go back to our running state. And here, this is the running state, by the way. If we actually swipe down, I'd like to change to a sliding state. So if input manager, swipe down, let's enter a sliding state. And right now I'm thinking, should we have any other means to enter the sliding state? And I don't think so. I think the only time you can enter a sliding state would be when you're running. So I think it's the only place where we actually need to branch into this state. That being said, let's try it again. Remember, I have a 5-second slide here. So I'm going to jump and try to slide over here. Oh, and it says process motion not implemented in that state. That's actually correct. I forgot to implement the process motion. But I've paused the game. Let's have a look at the... Okay, so the controller didn't get tinier. So it feels like there's an error here because I feel like I'm going to the state too fast and I'm coming out too fast as well. So let's check this out. I have a feeling that what might happen is because we are not actually pushing our player towards the floor, so process motion actually just stops us from moving at all, that we enter a falling state for some reason because we're no longer grounded. That is my theory, and that's what I think is happening. So what we're going to need to do is actually code the process motion. That's going to be very, very important. So that being said, let's go down here, public override process motion. And what we'll be doing here is something very similar as running. So I'll just go grab whatever we have in running. We're going to snap to a lane. We're going to make sure we're pushed towards the floor, and we are going to slide forward. Let's see if this works now. Okay, so I'm not getting any error, and I feel like if I just paused the game, by the way, I feel like my controller, yeah, it's a lot smaller. So if we just leave this running and we enter a different state, you saw that it went back to normal. So I'm looking at the green outline here, and I'm going to do it again here. So slide, pause the game, and as you can see, we have this small dude here. This is going to be very important for these type of object over here. Now, I have a feeling that we actually go beneath them even though we're not sliding. So let's see this. Oh, there was a small hiccup here, but it's not enough. So let me go on the prefab real quick and make sure this is smaller. A good thing with the fact that we've made prefab out of babies is I can just modify one and it's going to modify all of them. So I'm going to take the box collider, this one, and just push it a bit further down like so. And we're going to try this again. So I'm kind of unlucky. I need to have one of these spawn right now so we can test this out. And there should be one right here in the next prefab. Yep, here it is. So let's go in that lane and we should get stuck. Yep, so we're stuck here. Now, until I slide down, I should not be able to go beneath it. Now, obviously, we're gonna have to tackle these prefabs so they look a little bit more realistic, but let's go and swipe down. And as you can see, I went beneath it just fine. Eventually, in fact, very, very soon, these are gonna be killing us. So if we run into it, we should be pretty much dead. But as far as this episode is concerned, I'm gonna go back on my sliding state, make sure it's only 1 second, save this, and we are now going to have our sliding state. All right, so I'll catch you in the next one where we're going to start implementing the, I think we're going to be implementing the respawn and also the def, but very soon we're going to be implementing the animation, so this looks a lot better. Anyway, see you there. In the previous video, we looked into creating the sliding state, and it's something we now have part of our toolkit. We then have to create two more states. Those are the respawn state, the def state, but it's not something we'll be doing right now. I thought about doing them right now, but I decided that we should move them a little bit further in the tutorial when we have trigger for those. So at the moment, we have no way of dying. We have no way of respawning. This logic is not in there. And our prefab, they don't really kill us at the moment. We just walk through them until we decide to either move or slide beneath them. So what we'll be doing today is we'll head back to the animator. And we'll make sure that whatever we have right now, so falling, jumping, running, and sliding, those have attached animation to them, and we can make sure it's being called properly. It's fairly simple video, and it goes back to what we already saw in the past regarding the animator. So this state machine over here. So we'll be using these following parameters, the one that are included inside of the animator, something we saw a little bit earlier, I think in section number 2. So going forward, we'll be using all of these states. We'll be opening all of these scripts, and we will be plugging in the animator in there. So going forward, in order to actually hook this animator, the one that we see here on the screen, we'll have to go ahead and have a reference to it. Now, it's something that we could put under base state, but in base state, well, we have a reference to the motor, and we might actually want to use it here instead. So what we'll be doing is inside of the player motor, I'll be creating a public animator, which is going to be I'll just call it anim for animator. This one will be set directly in the start. So in the start, just beneath the controller assignment, I'll say anim is equal to get component type of animator. And now we have a reference to all of that.
This one is public, so do note that once we go inside of our state, for example, the running state, we can go anywhere and say, hey, motor.anim.set trigger or set boolean or set speed. All of that is going to be possible from this point on. With that in mind, let's go back to the four states we currently have. So I left them open here. We now have the sliding, falling, jumping, and running state. I'll start with the sliding one. And what we'll be doing right here is the following. So under construct, I'm going to be calling the motor.anim, and I'll actually do a question mark here, which means if it's null, we're going to stop right here. But if it's not null, let's continue. And we're going to do a set trigger. Trigger is going to be called slide or sliding. I'm not quite sure. We can actually double check in here. So here, the trigger is called slide with a capital P. So let's go back. Here it is. Now I can save this once more. And I believe that's actually all we need. Oh, no, wait. So once we're done with the sliding, we can also set a trigger back for running. Like so. So we should have everything we need for the sliding behavior to actually take place. Now, next up, we should go over to the falling. And when we enter our fall state, I'll actually have to override the construct. So once we enter the fall state, we can go ahead and set a trigger for that. So motor.anim set trigger, and I believe it's called just fall. Yep, so here it is, just fall. I believe that's all we need for falling. Next up, we have the jumping state, which I'll just copy what I have over here. It's going to be in the construct as well, and here it is being called jump with a capital J. And we can now give this a try. At the beginning, there should be a problem with the fact that as you can see here, we're not running. This is something that will be triggered later on once we actually decide to start the game. Because do remember that once we press play, we're not going to jump right into the content right away. There's going to be a screen stopping us. There will be two buttons, one asking for if you wish to play, and the other one asking if you wish to go to the shop. So once we click play, then we're going to set the running trigger, and then from that point on, we're going to head into jump, then falling is being called. And I am not actually transitioning properly right now outside of jumping. So we're stuck in the jumping state, which is kind of odd because we have fall triggered right here. And let's see what's the condition. Is grounded is equal to true. So we should actually be going back because now we're technically grounded. We should be headed back directly inside of the running state. So this turned out to be quite a simple issue. It was because is grounded was not actually being set. So on every single frame that I'm actually running the state machine, I'd like to keep a couple of values always updated. And those are the speed at which I'm going, and also if I am grounded or not. So these two here should actually be updated every single frame, not by a state, but by information we have outside of the state, so directly on the player motor. That being said, I'm now going to head back instead of player motor, and as we are updating the whole motor here, I kind of feel like doing it in between the transition here. Let's feed our state machine, our animation, actually feed our animator some values. And those will be the following. So animator.set boolean is grounded by is grounded. Let's see, I think I didn't put a capital. No, I did put a capital. Okay, I've always put capital. That's good. Next up was the set speed. So set float speed, and that would be, we would actually have to take the absolute value of vector z, but z is always going to be actually no, z is not always going to be absolute value, because for the def state, I wish to do some kind of bouncing back, which means once we go back towards the camera, this is actually going to be a negative z value. So I'll do a matf.absolute on move vector.z. And just like so, I think we just enabled the whole machine to work as a whole. So if we have a look here, at the beginning, we'll be setting a speed. Well, first, we'll enter the idle state. And then once we start running, we'll be setting a speed. The speed is going to be greater than 0, which will put us in the running state. And then from that point on, depending on whatever action you have, you'll go into one of these states. So let's give this a try. I am running, just not in the right direction. That's a jump and then back into running. Let's try sliding. Yep. So everything seems to work just fine in terms of the animation, except of course the fact that we're completely backward. But yeah, this makes a lot more sense than before. So now the problem we're running into is that it's completely backward, and that's only because the penguin itself is actually looking in a 180-degree angle away from where it should go. So if I put it back on 0 and I flip the camera to the other side, like so, flip its rotation as well, we'll now have something that makes a little bit more sense. But do note that we're about to change this camera as well, so we're about to go and modify this one to use in the machine instead. But it's a lot better now. We're starting to have a little bit of more. The game is starting to look a little bit better than it used to for sure. And then we'll quickly go into Cine Machine, make sure our camera are well adjusted, and then we can start implementing some of the logic behind the game, such as dying, respawning, and a little bit of the UI as well. That being said, we are going to wrap up this section fairly soon with the next video, and the next video is going to be all about adjustment. So things like the lighting not being all right, the actual prefab not spawning enough of it, so we actually see this behind, and also everything that has to do with the collider. So you see here, I get stuck in the ramp just because the collider is not properly set up, and maybe because my slope angle on the character controller is not accepting a wide enough range of angles. So next video is going to be a wrap up in which we're just going to make sure everything is a little bit more polished before we head into camera. It's important that when we start playing around with the camera, everything looks decent enough for you to position it properly for the final product. So we're not done yet with the player section, but we will be soon enough. And I'll see you guys in the next one. So welcome to what is going to be the final episode of the player section, in which we're actually going to do a little bit of polishing. We're going to be correcting some prefabs so they look a lot better on the camera, and when we do play, well, it just looks better. So if we press on play now, you're going to realize that we have a couple of issues. First, we see the blue over here, so we see the skybox. Definitely not something we want. We see items popping up, so that we can fix at the same time. What else? We have these very, very huge prefab that, they don't really work properly in terms of what we see versus what they are. So we're going to be scaling them down and also doing a bunch of little changes on the slopes. So yes, we've already made our gameplay prefab, but do know that we made prefabs out of the prefab we were using. So if we head in the folder over here, you'll find out that yes, scene chunks, here they are, and the gameplay chunk, here they are. But we can actually scale this down individually because that's also a prefab. So I'm going to open up the blocker prefab, this one, and I'm actually going to just scale it down on all the axes and just save. Now, with that in mind, it should have been reflected in pretty much every single thing that we have, so including here. Now, the next thing I'll do is I'll fix this slope over here so it matches the item a little bit better, and also it goes at the exact same height as this one. So if I was to just take this and maybe put the pivot point on the local axis and just move it up. Let's see, is that on the same level as the other? Maybe a little bit more this way. So just play around with the prefab a bit, and do note that it's on 45-degree angle. And what I'll be doing now is I'll head over to my player, just right here. Here you'll be able to see that the slope limit is 45, so that makes it very, very clutch. I'm going to up it to 50, so when I run into that, I never get stuck. And as you can see, it's a little bit smoother here. Now, I've done the changes, but not on this one. I might want to go and actually add some changes on this prefab as well. So let me just see if they are looking similar. Here it is. And this one seems to be okay. Maybe I want to up it just a tiny bit, like so. And this is in the ground. Next up, we're going to head over to our world generation. And over on the scene generation, we saw that 5 of them is not enough. So as soon as we start running, you can see that we see more than one. So obviously, we'll need a little bit more. So maybe up that to 7 or 8. I'm going to go with 8 because they're quite small right now. Make sure you change that while you're not in the play mode. And this problem should already be fixed. So
Okay, so this problem is done, but we can still see it a little bit sometime. If I jump too high, like around here, sometime you'll be able to see the blue and you see it on the left-hand side. Um, Everything that has to do with that, we will fix in I believe it would be the second or the next video. Simply because what I'd like to do is make sure I change all my floor. I get rid of all the plane and I just create one big plane. But that's something we'll do in a different integration, actually in the next one. But until then, we're going to keep on fixing some of the issues. And right here, I believe that we could go ahead and play with the lighting and make our game look a lot better, as you can tell, by just shifting the light toward this direction to whatever you like. So actually, what I'm doing right now is I'm changing it in the play mode, but I am just looking at what is good. And then once I have it, I'll copy those value like this. I actually like this quite a lot here. So I'll grab my transform on my directional light, copy my component, stop, and then paste my component value. And we'll end up with something like this. Now, most likely, we're going to have to relight this little section here and make it look better and maybe add a different light here. But for the moment, let's just focus on the gameplay. And already here, it looks a lot better. If we have a try here on these, let's see if this looks a little better. So yeah, obviously, if you hit this, you die. And then if you slide down, we actually don't fit. So okay, that collider is going to need to be a tad smaller. Yeah, it's very, very clutch. So let's head back and actually just up this a tiny bit. It's really important that you actually test those out as well. Yeah. So here it is. I'm just gonna up and we should be good to go. Yep. So we can get beneath them without any problem. One last thing that we have to do in this video, and it's going to be preparation work for once we have def logic, but at the moment we don't have any def logic. It's going to be preparation work for the next part, which has to do with putting colliders, def colliders, so things that will actually hurt you. So if I head over to this block, or any block for that matter, I need to know in which direction they are being spawned right now. So let's see. On a gameplay chunk, it looks like it's being spawned in this manner. And so if you see here, the pivot point is on the right-hand side, and on the opposite is where it's actually being spawned. So with that in mind, I'm going to head over to this block. Know that this side over here is where that's the actual front. I'm going to create a new collider beneath this object. So empty game object, maybe a cube for now, and then we'll remove the mesh. Just put it in front and scale it the way I wish. And that's going to be a zone that will kill you. So let's make sure it looks somewhat the proper size. So maybe something like this. And if you run into this, you are going to die. So here it is. Now, one thing that's going to be very important is to put this on a different layer, a different collision layer. And right now, I'll leave the mesh, but do note that we're going to turn it off, and it's just going to be a bounding box at one point. So as I've just mentioned, on the right-hand side over here, at the top right, you'll be able to find no layer regarding def. So let's create a new one. Go under Add Layer. I'll add one, call it def. And we will put this one on the def layer. Okay, so now all my block should have this in front of it. Yeah. And as you can see, you're not going to hit it if you just fall in this. And actually, you go so fast that you never really fall in this anyway. And here, however, if you run to this one, you are going to die. So be aware of that. Next up, let's see, where else do we need a depth collider? We don't need anything that kills you here. We, however, need something on the rock. And the rock as a whole could be a depth collider. So here I'll just put that on depth. Next up, we have the log. So that's the same thing as the first one. Actually, I'll just grab this one here and put it like so. and position it roughly to where it should be, so where it should actually kill you. So something like this. Yeah, okay, good. Now that we have this, I think we have everything. Oh, we're missing one, the blocker here. This whole thing should be a depth collider. So if you're hitting these border, you should die. And also if you're hitting this one, you should also die. All right, so we have that in store. I'm gonna go ahead and remove the last two meshes on this one. Just turn them off. I'm actually not going to remove them completely in case we need to modify in the future. And they should now exist. Awesome. All right, so this should be it for this episode within the player section. In the next one, because we're gonna have one more, we're actually going to make a floor that follows us, so we can start removing it around from our prefab, and we can have one floor, just one plane that is 10 by 10, and scale it up, have a different offset, have a different sampling size on our texture, and make sure it covers the whole ground. All right, so I'll see you in the next one. Okay, so previously we played around with the prefabs, making sure that they are ready for a game, that they're a little bit better to go over in case it's a slope, and we played with the lighting a little bit. What we'd like to do in this the real final episode of the player section is have the floor follow the player, and that is so we can clean up the rest of our prefabs and we can remove the floor, and also make sure we don't spawn a bunch of these because they're quite expensive actually. So what we're going to be doing now is first up, we will grab the floor out of the level. We'll grab the floor and we'll just put him outside of everything, and I'll call it snow floor. What we're going to do is remove the mesh collider because we have a mesh that has a little bit more vertices than it should. As you can see here, it's overlapping. We're actually going to remove that, and do note that those are important. We don't want to just go grab a we don't want to just make a four vertices plane in our case because we have to bend it with this shader. So it's important that it has a little bit more vertices than a four vertex corner plane. So yeah, that being said, we are going to go ahead and just remove the mesh collider. That is, however, not needed. We can use a box collider instead, which is a little bit less expensive on the CPU. Now with this snow floor, I'm also going to create a script called the exact same thing, so snow floor. And the logic around it is going to be quite simple. So here it is. I'm just going to drag it under, I believe it could be under world generation. And we are going to edit this script. Now here's what we're going to need. So let's get rid of everything at the top. Make sure we have a couple of reference. Those references will be two serialized field. One of them is going to be private transform. That is going to be the ground itself. And also another one that is going to be the material. So material. In a private void update, so every single frame, I'll actually use the ground. Oh, my bad. I meant to say here the player and not the ground. So I'll be grabbing a the transform of the player to know where he is, and then I'll be placing my floor beneath him. And now we're going to be setting the position of the floor. So the floor is just transform, and our transform the position as a floor is going to be equal to the player Z, but we want to stay on the y-axis 0 and also on the x-axis 0. So what you could do is either do a new vector and then 0, 0, and then player dot transform position, or you could just say, if you don't want to have to write the new keyword, you can say vector 3 dot forward times position dot z, like so. Now, if we're to play this, this is the behavior we're going to see. Unsigned reference. Okay, well, that's not a good start, but let's go ahead and add the material in there. The transform is going to be the penguin transform, like so. Now you'll see that we're moving along with our floor and it's right beneath us. It looks awful, but that's only because obviously there is still a lot of other planes around. So it's time for us to go and clean up those planes. Here under the first chunk, I'll remove this and I'll remove the second one. Hit save, second chunk, same thing. Hit save, and then the scenery chunks. Oh, I did have I believe I did have the mesh collider here. Were they any useful? I don't believe so. We had other colliders. I believe we had other colliders. Yep, here they are. So left plane, right plane, gone. Same thing here. Okay, now let's play this again. All right, looking a lot worse than it used to, but as you can see here, as I'm moving, um, at least it's staying in the middle on the x-axis, and also the behavior we're looking for is actually working just fine. What we'll need to do next is make sure we scale this one up. So it's going to be important that it actually covers the whole screen. So I'll go back on my snow floor and I'll make it say 20, 20, 20. Okay, as you can see, obviously there is some issues with the shader, but we're getting there slowly. What if we make it 10, 10, 10? So 10 on all axes makes it a little bit, it doesn't work with 10 on all the axes because it's a little bit short, but at the same time, as you can see, it looks like it's still eating a little bit of the model. So what we would need to do, so what we could do here is make a collage of 4 different floors. And that's a weird way to put it, but let's actually give it a try. So here, snow floor would actually be the parent object. And on the parent object, I'm going to make 3 children. So 1, 2, 3, 4. 2, 4. This one I'll get rid on the parent. I'll get rid of the mesh renderer, and I will get rid of nothing actually. So only get rid of the mesh renderer, then put the other snow floor beneath him. Under this, we can remove the collider and also remove the snow floor. So on all of them, no collider and also no snow floor. And let's move them around a tad bit. So I'll go back and I'll put that on 111 so I can edit better. But here, how it is going to look like. First floor is going to be right about there. So minus 5, 5. Second is going to be 5, 5. Minus 5, minus 5. And this one is 5, minus 5. So I hope you understand that the only reason I did that is so I could get more vertices. So a tad more vertices to play around with when I do scale this one up. So now if I go back to game and I am to scale this to 10, 10, 10, we should not have the same behavior as we just did. So it's going to be a tad easier first to see the end of it. And second, it should not eat as much as the model if we just go a little bit further than it did before. And it also allows us to scale it down. So let's see. 7.5 seems to work for me. Yep, and even when I jump, I don't see any glitches, any visual glitches. What if I do 666? The smaller you go, the better it's going to be with the shader because you're going to have more vertices in a smaller, in a smaller region. Okay, so this actually works fine with me. And now what we'll be doing next is make sure that the texture on the floor, it doesn't stick with us. It actually looks like it's moving, and that's a very fun part to do. So what we have to do next is actually tile the material with the shader we've made. So with that in mind, let me scale that back to 666, even maybe 555 or 5.5. Yeah, even that seems to be where. Oh no, never mind. I saw the skybox. So back on 666. Now we had a second property on this material that is the snow material right here. And this is where we're actually going to have to play around with the tiling that we've made in the past. So now what we have to do is play around with the tiling until this looks good. And let's see, maybe 15 or 20 seems to be the proper size. So if we do 15, it looks something like this. And that's already a lot better than it used to be. So I'm going to leave that on 15. Next up is the following. As the game is running, as my player is progressing, we're going to have to play around with the material setting and make sure that the offset actually moves with us. So as you can see here, we have to move this in a certain axis. Now, something that I don't seem to have done here is separate those axes. So maybe we'll have to go back in the shader and just make sure we're moving on the y-axis and not not the x, because right now, as I'm moving the offset, it goes in diagonal, so it goes like this, so from bottom left to top right. Instead, I just like to increase it in a linear manner on the y-axis. So first, let's go ahead and split this under the shader. Now it's something we can do simply because we made this shader. So let's go ahead and double click on main. That was the name of the shader. If you can't find it, it's beneath the rendering folder. And we were to change the offset right here. In this box, we used to send only one parameter, so one float that would go in both of the offset. Even though this was a vector 2, we sent it only one number and it just reproduced itself under the 2 component of it. So right here, under my blackboard, I have the offset that is a vector 1. And what I feel like doing is actually deleting it completely and creating a offset with a vector 2 instead. So offset, but this time it is a vector 2. So if I am to drag it here, I can now put it under here, and it should be a tad different what they give us under the inspector settings. So let me save this. No issue has been found. Let's open this one up. And now we have actually a vector 4. How come is this a vector 4 now? Okay, it says vector 2, but it's giving me a vector 4. Either way, we have what we need here. As we change Z and W, nothing happens, but X and Y, we get to have those changes. So maybe that's a bug on my end. I'm not sure. Either way, as we run forward, we're going to have to reduce the offset of Y continuously until the game is actually done. So let's give this a try. We are going to head back to our script. And right here, we are going to do the following. So we're going to call the material and say set property, I believe, or set float. Set vector, maybe? Yeah, so set vector. This one is called offset. And the value is going to be something, something that has to do with the player position in the z-axis. So I believe we could try a new vector 2. X is always going to be 0. And here, let's put temporarily, let's put minus the transform position.z. See what this gives us. Now, if I am to hit play, we are not getting the behavior expected whatsoever. So I'm wondering why this is the case. Set vector offset. Let's see. How do we call this one? Yep. So it is called offset. It is exposed. Maybe the reference here is what we're looking for and not that name. It can happen that this is it. Yeah, I believe this is it. So let me grab the reference, see if that's the problem. Now, if that's the issue, we can rename it, no problem. Okay, that was definitely the problem. So as you can see here now, all right, so as you can see here, I'm clearly going way too fast, but this is the reference we need to change. This is the name of the offset. So let me just rename that to offset itself. Oh, and what's the problem here? Okay, let's call it something else. Snow offset. It seems to cause a lot of issue with the rest of the scripts. And that's what we're going to be calling it. Now, in terms of the in terms of the speed at which this should go, now that we know that we're moving in the right direction, and this is a dynamic field that will change eventually, as long as we go forward, this is going to change. So this is going to be our dynamic value. Now we would need to multiply it with a certain constant that has to do with the sizing of our texture and also how big we scaled these objects. So this floor here is, for example, this one is 6, and then beneath it, these are all 6. So technically, we should consider that those are all 6 in scale, and then there's the number 15 here for the tiling purpose. So I'm not quite sure how we're going to do these math. Let's see what makes sense. So if we're to do, no, that doesn't make sense. What I'm going to do is actually make this a public value, and we're going to play around with it at runtime. So public float offset speed, and for the moment, let's put 0.2, see what this gives us. So if I am to run this and I go on my snow floor, see this one looks already a lot better, but we're still moving a little bit forward too fast. So which means we would have to increment, I believe. So on 0.25, it actually looks good. On 0.25, it doesn't look like it's moving whatsoever. And that's the behavior we're looking for. So it must not look like it's moving unless you like that effect, really. I believe you could say that you're like falling down a avalanche. So really the value that works for me really well was 0.25, and then it just looks like it's right there, it's staked on the floor. So I'm going to go ahead and do 0.25 to make sure I don't lose this value. I'll also change it here in my script as well, but make sure it is reflected under here, under the inspector. So this pretty much concludes this episode. What we really had to do is make sure we had one big floor that every time we look around, looks like we have infinite floor. And instead of having a couple of planes, so a lot of different planes, now we only have four, and they're going to persist for the rest of the game. And if we actually run into a wall, the scrolling is going to stop. So as you can see, it doesn't look like it's moving, and that's the behavior we're looking for. And that's it. So thank you so much for watching this section. In the next one, we're going to start playing with the game flow. So we're going to have some logic in there that makes it so you can actually die, you can have different camera angle, you can respawn, and maybe I believe we're going to be tackling a little bit of the whole flow of the application. So we're going to have a dev screen, and then maybe the respawn state is going to be in there as well. That being said, I'll